We're going to look at some basic skills for wiring, and we'll also look at some plumbing skills, but let's focus on the wiring, valve wiring and connections, low voltage connections that we would make to connect our irrigation controller to the valves in the field. It's a similar thing that we do when we do landscape lighting. But in this instance, we're talking about connections to control wires from the clock. So these are a 14 gauge wire. This is a little bit heavier duty wire that you will oftentimes see used. It's what's used here in the Lifescape garden. The longer distance you have to travel with your wiring, the heavier gauge you want to have for your for the wire, so that you can carry that current efficiently and not have resistance and voltage drop. Apparently electricity works a lot like water. When we talked about pipe sizes and resistance in pipes to flow, we have the same thing with electricity. It's not exactly the same, but it's analogous. So we need a larger wire to carry a signal a longer distance with less resistance. The thicker the wire, the less the resistance. Just like the wider the pipe diameter, the less resistance we have in the flow of water in pipes. So think of it as a similar thing with electricity and low voltage wiring for control wires. The longer distance you've got to go, the more heavy gauge wire you want to have. So to strip the wire, we strip this. This is a stripped end here. We want to go to our stripper, and your wire stripper will have different gauges on the stripper. So you can find the 14 gauge notch in the stripper and do that to pull off the little cut and remove the insulation from the outside of the wire. So oftentimes if you have you may want to do several little bits of removal rather than try and do it all in one bite. Sometimes, depending on the wire, it's easier to take two little pieces off than to do one piece entirely. So we're going to strip our wire ends. Here's the other wire we're going to be marrying to that one. So we find our 14 gauge slot and take off the insulation. So we're going to marry these two together. And what you want to do is put them together. This is pretty completely obvious and simple. Take your gel-filled wire nut. This is a wire nut that has a silicone gel on the inside. That dielectric gel is there to insulate and keep the wires from corroding. You're going to be burying these in the garden. They're prone to getting wet. And when raw metal is left wet in the environment, it can start to corrode, and that can influence the connection, start to make the connection less secure. So we use wire nuts that are full of a dielectric gel that insulates and protects the wires from moisture while in the field. So we want to take that wire nut and insert the wires into the bottom of the wire nut and begin to twist the wire nut down. And you'll feel those wires twisting inside the wire nut as they go down. You want to get a nice snug bite, but don't over tighten it, so that you get your two wires connected into the wire nut like so. And that is how we do wire nut connections. You also might find, as we said, it's more common to find a smaller gauge cable. This is a multi-stranded cable. You can see that this cable has in it many different colors. This is a 5-strand cable. It has 5 different cables smaller cables on the inside. So let's take this outer insulation off of this so we can see the different cables on the inside. There's red, white, blue, green, and yellow. So we have 5 different possible leads in this cable, and we can do the same thing with this. This is a smaller cable. This is, I believe, a 16 gauge wire. So if we want to strip this, first of all, let's take a little bit more off. To just remove the outer sheathing, you want to be very delicate that you only cut through the outer sheath and don't nick the insulation on the colored wires on the inside. So you take that, cut it off like that, and pull off the outer sheath. So that gives us a little bit more room. You can also use, there is a nylon thread that is part of the cable. It's in there partly for strength, but also it allows you to, once you get a hold of the nylon, you can sometimes strip the cable down by pulling on the nylon. If you get a little cut going in the wire, the nylon will split the wire open. Sometimes it does not work with. What I really need is a little knife to get a slit started in the sheathing. Anyway, just know that you can. Oh, Lewis has a knife. Perfect. So what we can do is take the knife and make a little bit of a nick in the sheathing just to get it going there. Being very careful with sharp objects and exerting force with sharp objects to be sure you're out of the way. But once we get that down into the once we started a little split, we can now take this thread and pull it, and that cuts through the sheathing. So that allows us to strip out a fair distance of the outer insulation and protect our wires. It means we don't have to keep cutting with the other, with a stripper to kind of remove the outer insulation. We can just cut that insulation off, split it back with this thread. That allows us to expose a lot more of the wire. So then, if you remember, white wire is our common wire, so you'll always find a white wire in your bundle. And then red and blue are the next two most common. And then yellow and green typically is what you find added in a 5-strand. When you start getting up into 12-strand cable, they're cables with multiple strands. You start getting other different colors like orange and purple and pink and what have you. So just know that the smaller the bundle, the less number of leads there are, the more likely you are to center around these core colors. And red, white, and blue, if it's a 3-strand cable, it's typically red, white, and blue. So just know that those are the colors you'll be dealing with. Stripping this out, again, same thing. You find the, I believe this is going to be 16 gauge. You find the 16 gauge notch and pull the insulation off and expose the cable there. If you're going to marry it to another cable, you take those two, put them together. Don't have to twist it to start with, just be sure they're nicely together. Insert them into the cap and begin twisting as you're going down with the cap. Let the inner mechanism in the cap grab the wires and twist them together, and there you end up with your connection, a secure, watertight connection. So this is how we do our low voltage connections using gel-filled wire connectors. So it's important to use the gel-filled, don't forget that part. But that's how we do our wiring. Okay?